The professional logger felling timber in the woods has two main concerns: safety and efficiency. Directional felling through proper notching and backcutting techniques is the key to both of these concerns. Directional felling means that the cutter is at all times in complete control of the timber he is cutting. It means that the feller and his crew are protected from the hazards of timber falling out of control. And it means an orderly felling pattern that allows faster, easier, and safer limbing and skidding. In this program, we will examine the three basic types of notch: the backcut and the hinge, and the notching and backcutting techniques that add up to safety and efficiency in directional felling. The first step in felling any tree is to assess the tree, the area, and the escape route. Factors to consider include the natural lean of the tree, any heavy branches on one side that could affect direction of fall, snow or ice loading, the wind, direction, and speed, branches that are bound in with the neighboring trees, other trees or ground obstacles to avoid hitting, and of course, the skidding pattern itself. A good work area with solid footing clear of underbrush, branches, and debris is needed. This means cutting small saplings low and flat to the ground to reduce tripping hazards and prevent damage to skidder tires. The escape route, the safest direction for the cutter to retreat, extends back and away from the tree at a 45-degree angle. It must be brushed out and ready for use when the tree starts its fall. There are basically three types of notch that will be discussed in this program: the conventional notch, the undercut or Humboldt notch, and the V-notch. Each of these notches is best suited for use under certain conditions, but all three work on precisely the same principle. Each notching system consists of three basic parts: the notch itself, cut in the exact direction of intended fall; the backcut or felling cut that allows the tree to fall; and the hinge, the strip of uncut wood between the notch and the backcut that holds the tree in position so that it falls under control in the intended direction of fall. The function of the notch is to allow the tree to fall in the intended direction before binding on the stump. As the tree falls, the trunk and the stump fold together like a mitered joint. When they fold together, the hinge is broken, and the tree continues to fall to the ground. The backcut, made directly opposite and 1 to 2 inches above the notch, severs enough of the remaining wood fibers to allow the tree to fall. The hinge, or the uncut holding wood between the notch and the backcut, holds the tree in position while it falls in the direction of the notch. The first step in the felling process, then, is to choose a target in the desired direction of fall. Where possible, the notch should be from the right side of the tree. If the left shoulder is placed against the tree and the body positioned behind the saw, the sighting lines on the saw can be aimed exactly at the selected target. Properly positioning the notch is very important. Even a fraction of an inch offline at the stump can mean that the top of the tree will miss the target by several feet. The first type of notch that we will look at is the conventional notch. It is the notch most commonly used and is the simplest to make. It should be made with the left hand on the corner of the forward handle of the saw so that the first cut is made sloping downwards at an angle of about 45 degrees. It should extend to a depth of about 1/3 of the tree's diameter. The depth of any notch should be about 1/3 of the diameter of the tree, but can vary from 1/4 to 1/2, depending on the circumstances. The width of the notch should be as wide as it is deep, or 45 degrees, to ensure that the hinge wood doesn't break until the tree is committed to falling in the desired direction. If the notch is not properly positioned, the tree cannot be expected to fall where intended. Once this cut is made, the cutter can look down at it while making the second cut straight and level. Both cuts should then meet cleanly, and on completion of this second cut, the wedge of wood should come clear of the tree. The mouth of the opening will be roughly equal to its depth. Before leaving the notch, it should be examined to ensure that both cuts meet cleanly. The direction of the notch can also be verified by placing the bar of the saw into the notch and using the sighting lines to confirm that it is lined up with the target. The backcut is again made directly opposite the notch. It should be level and 1 to 2 inches above the notch. It severs enough of the remaining wood fibers to allow the tree to fall. Since the sloping cut of the notch is made on the trunk of the tree, the falling tree may tend to ride up on the stump and slide back towards the cutter. The backcut placed above the notch creates a ledge or a step to hold the butt and prevent it from sliding back. You should stop cutting the backcut when the tree begins to fall or the proper amount of hinge wood is left. In some cases, perfectly balanced trees may require a felling wedge. The Humboldt notch is essentially a reverse of the conventional notch. The first cut is made sloping upwards into the trunk at a 45-degree angle to a depth equal to about 1/3 the diameter of the tree. The second cut is made level to meet the first cut cleanly. The back cut is made an inch or two higher than the level cut of the notch. The Humboldt notch has several advantages. First, it's safer than the conventional notch. With the sloping part of the notch cut into the stump, the falling tree will tend not to kick back at the cutter. Part of the stump is cut into a ramp, and the butt of the falling tree will slide down and away. Secondly, the Humboldt causes the falling tree to slide down and land clear of the stump, where it's safer and easier to work with. And third, it is more economical and produces a better quality log, simply by cutting the notch out of the stump rather than out of the butt of the log. On some of the larger diameter saw and veneer logs, the difference in value can be very significant if that first butt log is downgraded due to the removal of the notch material. The V-notch is used for felling larger diameter trees on steep slopes when the falling tree will fall downhill and swing past the horizontal before severing the hinge. The V-notch is made with two sloping cuts, one sloping downwards, the other up. The two cuts should meet cleanly 1/3 of the way into the tree, and the notch will have a mouth much wider than its depth. The back cut, again straight and level, is made an inch or two above the back of the notch. This notch gives the tree a larger opening to close as it falls, so that the hinge is not broken until the tree falls past the horizontal. Some trees, especially the larger diameter hardwoods and those with a pronounced flare, require an additional step in the felling process: cornering cuts. These cuts are made to a depth of an inch or two at the leading edge of the notch on both sides of the tree. They're flat and at an angle of about 45 degrees to the direction of fall. Cornering cuts are designed to sever the strong sapwood fibers at the outside of the tree to prevent side scarring and damage to the butt of the trunk. All three notches have one more thing in common: the hinge. It's the hinge that provides control, and it's the hinge, not the notch, that ultimately determines the direction of fall. A tree with a properly aimed notch, but without a hinge, could fall in any direction depending on lean, weight distribution, or wind speed and direction. The hinge is a solid strip of wood It should be about 1/10 of the diameter of the tree that is left between the notch and the back cut. A hinge on a door allows the door to swing in 2 directions only, open and shut. Similarly, the hinge on the tree allows the tree to move in 2 directions only, forward into the notch or straight back. If there is insufficient lean or weight in the desired direction of fall, a felling wedge is used to prevent the tree from sitting back. As the tree starts its fall, the hinge keeps it from any sideways motion until the tree is committed to falling forward. There is one hazard that is common to all 3 types of notch: overcut notches. An overcut notch is made when the cutter overshoots one of the cuts of the notch. It means that the 2 notching cuts do not meet cleanly, and that one saw cut extends beyond the notch into the tree. When a tree with an overcut notch starts to fall, it closes the overshot saw cut first, and as the trunk contacts the stump, its fall is momentarily interrupted. The tree hesitates in its fall, and a great strain can build up. The tree could break the hinge off permanently and fall out of control. It might split up the middle in a barber chair, or it might pull fibers from deep within the trunk before falling. All 3 possibilities place the cutter at risk from an unpredictable fall, and all 3 situations also mean dollar loss when a tree is downgraded due to overcut notch damage. The time to correct the overcut notch is immediately after the notch is made. A single saw cut to enlarge the notch and meet the under or overcut saw cut eliminates the hazard. The stumps and the butt ends of felled trees leave a permanent record of every cut and show clearly how the felling was done. It shows whether a proper notch was used, if the back cut was level and high enough, if appropriate hinge wood was left, and if an overcut notch was made. Checking stumps is a good way for the cutter to assess his own work and identify any areas that require improvement. As a professional logger felling timber, you have 2 main concerns: the safety of yourself and your co-workers, and the value and efficiency of your work. Proper notching and backcutting techniques allow you to achieve both of those goals. Every part of the felling operation fits together to make the job safe and efficient.